we talk about modern AI models, like large language models or computer vision systems, they're powerful, but also extremely heavy. They require massive amounts of memory and computing power. This makes them hard to run on everyday devices like laptops or phones. One of the main techniques used to make these models smaller and faster is quantization. At its core, quantization is about reducing the precision of the numbers inside a model. Neural networks work by storing millions or billions of parameters, and those parameters are usually represented as 32-bit floating point numbers. That's a lot of detail, more than is always necessary. Quantization replaces those 32-bit numbers with lower precision alternatives, like 16-bit, 8-bit, or even 4-bit values. The idea is simple: use fewer bits per number, which saves memory and speeds up computation. Imagine you're saving photos. A raw image file gives you the highest possible detail, but it's huge. A JPEG compresses it to a smaller size. You lose some precision, but the picture still looks almost the same to the human eye. Quantization works the same way for AI models. It compresses numbers while trying to preserve accuracy. There are three main benefits. Smaller models. Quantized models take up far less storage, which is critical if you want to deploy them on mobile devices or edge hardware. Faster inference. Lower precision arithmetic is quicker to compute, which means faster responses from the model. Lower energy use. Since the processor does less work, quantization can make models more energy efficient, important for both cost and sustainability. There are several ways to quantize a model. Post-training quantization. You train the model normally, then compress it afterward. This is the simplest, but sometimes leads to a drop in accuracy. Quantization-aware training. Here, the model is trained while already simulating lower precision. The network learns to work with the limitations, so the final accuracy is usually better. Mixed precision. Not all parts of the model need the same level of detail. Critical layers can stay at higher precision, while less sensitive layers are reduced. This balances performance and accuracy. Quantization isn't free. Lowering precision can degrade model quality if done aggressively. For example, reducing to 8-bit usually preserves performance quite well, but dropping to 4-bit may cause noticeable accuracy loss unless handled carefully. So, engineers have to experiment, finding the sweet spot where the model is much smaller and faster, but still good enough for the task. Quantization is one of the reasons we're seeing AI move beyond the cloud and into devices people carry every day. For instance, language models that once required powerful servers can now run on a smartphone with quantization applied. It's also essential in industries like robotics and IoT, where running AI locally without constant internet connection is only possible thanks to these efficiency tricks. In short, quantization is a compression technique for AI models. By reducing the precision of numbers inside neural networks, it makes them smaller, faster, and more efficient, while keeping their intelligence mostly intact. Without quantization, deploying AI at scale on billions of devices wouldn't be practical.